Okay, so can you see my screen, all of you?
Yes.
Okay, so we discuss about the now if you want to implement the GitOps, there are multiple operators are available. One of the operators which we are focusing is Argo CD. Okay, so you can also check it out offline. These are the operators. It will help you with that. Okay, so now coming back to the history and overview of Argo CD. Now this is all about the Argo project. Okay, so group of 4 core solutions for orchestrating the container workflow. What we basically which we have as part of the as part of Argo project, we have 4 products which is very much popular, in order to orchestrate the container workflow. Which are the products which I am talking about? So one of the product we call it Argo workflow. Okay, Argo workflow. Second product which you are talking about is Argo CD, the one which you are learning. Third product which we are talking about, Argo events. Okay, and fourth one, Argo. There's one more project which I am forgetting. Argo events. Let me show you that page itself. So here, Argo projects. This is the page, official page. And now workflow. So rollouts. So these are the 4 products we are having as part of Argo projects. They have a few more products which is under development, and you will see on their GitHub website, so which you can check it out. So workflows, CDs, rollouts and events. Now these are the 4 products out of which we are going to focus on normally one product which is CD, but we'll discuss a little bit of it for each one of these. So Argo workflow project, which is basically an engine for orchestrating parallel jobs on Kubernetes. Okay, so this you can say something like a CI, something correlated to the CI. Now Argo CD, which is declarative continuous delivery, GitOps operator for Kubernetes, which we've been discussing. Third one is a rollout. Argo rollout basically is for the advanced deployment capability such as blue green, Canary and Canary analysis and stuff like that in Kubernetes. By the way, I would like to know which are the deployment strategy which Kubernetes supports by default. Anyone? Deployment strategy.
Didn't get you.
Hello.
Yeah, thank you.
Yeah.
So it has
Yaman?
it has, I don't know what's the exact name, but
I
some of the
know
rollout
that you know
strategy.
that. It's just a matter of recalling the keyword. Because
Right.
if you have used the deployment, without that we cannot use the deployment.
I mean, there is a rollout strategy by itself, right? I mean,
Yes,
that's one of
yes.
the,
So there are
yeah,
strategy. One strategy is rolling update strategy, and
right.
one
Rolling
is
updates, right. That's the name.
and recreate strategy. Okay. So I'll share some of my reference. First of all, Kubernetes deployment strategy devops. So here I have explained a little bit in a detailed way these 2 strategy which we have, recreate and rolling update. What are the difference? You must spend some time here. Okay, that is one thing, and I would like you to also spend some time with this also and this page also, and this contains all the strategy which we know. It's a very good image, I got it from the Google, and it has been explained throughout this session, but this through image itself, okay? No write up you have for this. So let me put it in the context now. So if you want to implement the blue green, which is not a part of the deployment, Kubernetes deployment, or Canary, which is not a part of the deployment, Kubernetes deployment, then you can use Argo rollout product. Very nice product. And then event driven workflow automations framework for Kubernetes. So you can use Argo events. 4 products we have, out of which one product which you are focusing is CD. Okay, so Argo CD is the core component of Argo project. Argo CD is a GitOps operator that provides continuous delivery for Kubernetes, which we know that by now discussions. Has application controller, okay, to continuously monitor apps running on Kubernetes, comparing the live app state against the desired state defined in the Git repository. Now, the statement is very clear, but I want to complicate a little bit. So do you know controller, right, in Kubernetes? In Kubernetes? Hello?
Yeah, trying to relate to it as a specific term. Uh, are you talking about an inbuilt component of
Yeah,
Kubernetes or?
I'm talking about the inbuilt Kubernetes component, which we have a controller. And now we have a controller manager also, correct?
Correct. Controller manager sounds familiar.
Yes. So now the question is, what is controller and what is controller manager? Anyone? I know that you know, it's just I need to recall the discussion. I mean, theoretical part of Kubernetes. And why you should know, because this is, if you really want to know how Argo CD works, you should know this controller. Okay, so for time being,
Replica set.
do you remember that? Controller control something. Something means one thing. Means each controller control one thing. For example, simplest example, let's say, do you remember that replication? Do you know that deployment, right?
Right.
Application controller.
Yeah, deployment has a multiple functionality.
Mm-hmm.
Major two core functionality which we have is a replication and controller, correct? Deployment. Replication means it can replicate to multiple pods as you wanted, and the second functionality which we have is controller. That means if you say, hey, my desire is 5 pods, this controller will always make sure that it is a 5 pod, not a 6, not a 4. Correct now? So deployment have a two feature, which one is called controller and one is one is called replication and one is a controller. Probably I'll write it. It will be easy for you to memory to store this data. So here, understand this. This is the deployment, and deployment have a multiple functionality. We have a functionality which is called replications, plus it has a controller, okay, plus we have a versioning, plus we have rollout, and plus rollback. These are the major functionality. Now I'm talking about these two. So replication and controller. So deployment have replication and controller powered by which resources, which API resources on Kubernetes?
Yeah, you mentioned control managers.
No.
Controller.
No,
Cube API.
deployment has a two feature, which is replication plus controller. Replications means you can replicate to as many pods. I'm damn sure you might have
Right.
done scaling, right? Scale for,
Yeah.
yeah, damn sure. And controller means have you deleted any pod for the deployment, that will be recreated automatically, right?
Correct.
Mm-hmm.
Yeah, so that's called desire versus actual. So actual will be maintained and desire will be maintained by controller. So let's say you say deployment and 5 replicas, it will be 5 replicas. If you say 100 replicas, it will be 100 replicas. So who's in charge of it? So controller. Now the question is, my question is, in a deployment, which API resources which empower these two functionality to the deployment. So guys, this API resources, we call it replica set. Have you heard about this?
Yeah.
Yeah.
Heard it.
Yeah, so here deployment uses the replica set. If you describe the deployment, you will see that controlled by replica set. Correct, na?
Right.
Mm-hmm.
Yeah. Now this replica set, the older version of it, we call it old version of you call it replication controller. Have you heard about this? Hello.
Yeah.
Yeah.
So guys, this is the replication controller, new version, we call it replica set, which is embedded in a deployment, which manage your desire versus actual. This is what I want to tell you. Now coming back to my primary question, what is controller? So guys, controller is very simple thing. We have a controller, control something. Something means any resources, any one thing, control something or one thing you can call it. Okay, now I'll simplify more easier way. Monitor something. Monitor something. Okay. Now this monitoring, this is done in the loop actually. Remember, loop means it never end. For example, there is one controller automatically when you bootstrap a node. Remember that you when you bootstrap a node, you know when I say bootstrapping a node, that means adding a worker. When you add a worker, then there will be one controller created in a controller manager, and that controller will keep checking. Hey, are you running? Are you running? Are you running? Are you running? I mean, it's like that, checking the heartbeat, kind of it. Some controllers will check the node. Some controller will check the number of pods. Some controller will check something else. So different controllers, types of controllers. Some controller will check the namespace, CPU utilizations. You remember that namespace, you set the limit range
Mm-hmm.
and stuff like that, correct? Hello? Hello?
Yeah. Can you
Yeah.
hear me?
You're on.
Yeah.
Now we can
So
hear you.
yeah. So here controller means control something which runs in the loop. So now there is one controller. So in Kubernetes we have multiple controller. Now this controller is where? So you can find in controller manager. And I'm damn sure about it. This is the component you know about this master. Correct now?
Right.
Mm-hmm.
Kube Controller Manager, and I think now
Yes.
they've introduced Cloud Controller Manager also.
Huh. So here, this is a controller manager. It's a manager for managing multiple controller. And each controller controls something. Something means node is attached to the master or not. Number of pods as part of this deployment or not. Like that. Understood the controller means?
Right. That.
Now guys here, let me tell you here, the question is how this Argo CD will check your desire which you write in where? Yeah, in a Git. You write your desire in Git. And what it's there in the Kubernetes, how they will manage it. So they require controller. This controller, you can write your own controller also. You can write your own controller. You can write, see, I'll put it a simple way, master. We have API server, think simple, okay? And we have etcd, and then we have a controller manager, and then we have scheduler. These are the primary component. Agree with me?
Mm-hmm.
So here, when you say you can write own resources, what we call it? When you write own resources, what we call it?
CRD
CRD, custom resource definition.
definition.
Here you can write your own controller. Yes, I said not controller manager. I said controller. You can write your own. What do we call it here? Any idea? Operators. What do we call it?
Operators. Okay.
Sorry about this. See, have you studied this operator concept?
Yeah, we are kind of familiar with operators and
Yeah. So operator
Shift.
is nothing but a controller. See, operator is nothing but a kind of controller. Okay, custom controller, a custom controller. You can replace scheduler. Scheduler means this is the one software, SCHEDUL. You can have your own. ETCD you cannot replace because of backend persistent storage. So basically, you can add more resources here. You can add more controller in form of operators and schedulers. So here, what I'm talking about now, coming back to the topics, here I said, hey, Argo CD has application controller to continuously monitor applications running on Kubernetes cluster, comparing the live app state against the desired state defined in the Git repository. That means, in a simple way, there is a controller written by Argo CD which will be running in a Kubernetes cluster. What they will do? They will check what we have in the cluster, and what you have in the Git, and they'll tell you whether your application is up to date or not up to date, sync or not sync. Are you understanding that? That's a job of Argo CD. That's a major job of the Argo CD.
Here, the term application, is it limited only to deployments or is it beyond that?
Yeah, what you said?
You said this has application controller to continuously monitor apps.
Application controller means this this controller this controller is having multiple kind of controller. So controller means here this one more controller will be added, that we call it application controller, is Argo CD controller. Are you understanding?
Yeah, yeah, okay.
Your own controller, in simple way, Argo CD controller you can say.
Hmm.
See, there's a two kind of controller. System controller, which manage the Kubernetes, the one which you are using by default unknowingly, knowingly. And there is an application controller. So for example, I'll put it in this way. So I'll put it in this way. So tomorrow, you create one CRD. Think simple, okay? You created a CRD, and CRD means your own resources. And in that own resources, you say, whenever I use kind, okay, then I should get pod 5 and service 1. I'm just giving you dumb example, okay? So you'll get pod 5 service 1 of that particular image. This is your custom resources. See, there is no as such human resources which will give you both of this, correct now?
Right. You'll have to
So
create them explicitly.
So you have to create. Why you created? Because you see that you are an enterprise architect. You see that, okay, in my organization, every time people are creating pod service, and so what should we should do? Let's automate this and create CRD. So now next time they will not use pod and service. They will use this kind, what, POS, pod service together. This is a new kind altogether, right? Hello.
Yeah, yeah. Okay.
Okay, so now you created a CRD. Now the question is, how can you make sure that whatever you specify, it should be always 5 only. Then you will develop one operators also. There's a multiple ways to develop operator, okay? So you'll develop operator and they will check the kind pos, the pod always should be 5. Always should be 5. So that operators is equal to controller. So custom controller is equal to operator or application controller, whatever you wanna call it.
Okay.
Got?
Thanks. Yeah. This is a KTS 1.23 kind POS.
Oh, no. This I'm talking about your own. You created resources. This one.
Okay, okay. Custom
It's
cursor.
not
Okay.
it's not given by Kubernetes. CRD.
Got it.
Remember, CRD means you
Right,
have
right,
created.
right. Custom.
Yeah, I created POS means P I have taken from here and S I have taken from here.
Okay.
Okay.
Yep.
Okay, so these are the primary major features which you have in Argo CD. Again, limitations I'll discuss tomorrow. Okay, not today because you need to play with it. Argo CD. So Argo CD is the core component of Argo CD project. Argo CD is a GitOps operator that provide continuous delivery. Continuous delivery. If you don't know the concept, spend some time over there. I assume that you know that by default for Kubernetes, and has application controller continuously monitoring apps running on Kubernetes clusters, comparing the live app state against the desired state defined in the Git repository. So these are the histories of Argo CD development. So initially this one organizations which is called Aplatix, which is a startup which launched this project, Argo concept, all this thing, all the different projects. And in first launch which they made it Argo workflows. Basically they wanted to automate entire things from in the container world. Okay. So the first project workflows, which is you can say CI also if you don't like, and you can say you can correlate Argo workflows with a pipeline actually. Okay, and after that in 2018, Intuit acquired this product organization, and in 30th 2018, 30th of August 2018, Argo CD officially announced, and now whatever that Argo CD we have, we are learning it. Okay, so these are the top Argo CD features. One use like you get an interface. So I'll show you that in just few minutes. So after installations, and here automated deployment of apps to the Kubernetes cluster is become very easy. And then health status of app and its resources. These are the major features of Argo CD. When you talk about the in terms of user perspective, okay. When you talk about the admin perspective, that's a different feature list. I'll show you tomorrow. So today we are focusing on the user part of it. Okay, so these are the three features which we have. Now, what is the standard workflow? So standard workflow, this is without Argo CD, okay. So you see that same thing I discussed in the morning also. So you have a source code. Look at this very carefully. You have a source code, you write a code and push it to the Git. After the CI, you do that build, compile, and you create an image. After that, you deploy it to the some in test environment, that image. Okay. And app repo means that image which you stored some places in registry. That's an app repo on top. Okay. And then you do the testing, all sort of testing. And once this is done, after that, what you do? You manually deploy to the production. So this manual works, what you see, wall, there you make a lots of issues actually. Lots of issues means manually when you do the things, you know that you will end up missing something, losing something. So that things we want to automate. This wall you see between the CI and CD is in Kubernetes. It was not automated. So we want to automate this one also. So no more manual deployment. So earlier what we used to do, used to use kubectl apply, right? Correct now?
Mm-hmm.
Right.
Yeah. So now no more kubectl apply, no more Helm install. You just simply use the CI, I mean Argo CD, and whatever you declare during the development, same thing will be deployed in the productions. So that's the way. Again, you have branching in Git. You have branching functionality. You can create a multiple branch for the same desire and all. So, anyways, I'll teach you that. So that's a one problem which is solving. That's a wall which you have between the dev and operations that you are building up, bridging. I mean, filling the gap using the Argo CD. So yes, Argo CD operator. Look at the workflow of Argo CD. Argo CD operator pulls app configuration from Git repo. Okay. When I say app configuration means nothing but YAML file. Okay. Helm charts and all, or Kubernetes file, customize and all. So Argo CD operators pulls app configuration from Git repo, deploy the app in a Kubernetes cluster. That's the first thing automatically. When new app feature code committed in the Git, pull request is submitted to Git repo to modify app deployment. Pull request is merged with the new code into main repo. So the moment pull request is accepted, Argo CD operator, see, don't get confused with the keyword. I've been trying to simplify. Operators means controller. Okay.
Right.
So technically, when you say operator means we are talking the C tool, but technically it's a controller. Argo CD operator does a pull to Git repo, see changes, and update app in the Kubernetes cluster. That's all the three things is been done by the CD, and you can visualize it through UI. Understanding all of you?
Yep. So
Mm-hmm.
what kind of changes? I see the triggers. These are all triggers for Argo CD.
Yeah.
So one is a pure application context. One could be some declarative statements in some YAML file. All of those are considered as changes, right? If you make
Typically,
changes.
your YAML is your YAML file, the one which you have, or Helm
Mhm.
package what you have is called changes. So let's say version 1, version 2. So Helm package you'll create, right? Version 1, version 2. Or let's not complicate Helm package because I think one of you not comfortable with it. So in that case, let's YAML file. Let's use the YAML file. So YAML file version 1, version 2. Like that.
Right.
Correct, no?
Yep.
So
The same context applies beyond YAML also, right? It could be um, any source code which has been compiled and made available in a repository.
any file which is you are trying to deploy through declarative language, I'm putting a very global statement. any any deployment where you are using declarative language, Argo CD can be used.
Okay.
We are
So then
using
it's
Argo
pretty much
CD in
YAML.
case of Kubernetes because container is dominant today. Maybe tomorrow some other declarative platform you will get it, so you can deploy. For example, OpenShift is again Kubernetes platform itself for our enterprise. So, for OpenShift there is a declarative language only, but different way you write it, right? That package, correct?
Right. Mhm.
So like that. Okay, so understanding the Argo CD core concept and architecture. So look at this. In Argo CD, when you install, you will have API server, you have a repository server, and you have a controller manager, a controller application controller. See, architecture means, see, when you install the Kubernetes master, you have API server, and API server, what you have? You have a lots of resources. If I remember, 56 resources you have, which is given by free of cost by Kubernetes, and till last month. And you can have as many resources created through the CRD operators and all stuff like that. etcd, controller manager, and scheduler. But when you deploy Argo CD, you will have API server, you will have repository server, now you'll have application controller. Let me put it up in a simple way. Let me ask you one thing. Tell me that API server is installed in the master machine in what format, in what form? Hello.
When you say form, what do you mean by form?
Container.
Okay, I'll put
Since
it in this way. Uh, API server is pod or what? Hello. Is it a pod
yeah,
or not?
it is.
It is a pod, right? Now?
Mm-hmm.
Because in Kubernetes, anything you deploy, it has to be pod. Correct, no?
Hmm.
Mm-hmm.
Yeah, this is a pod. etcd is also pod. Okay. Controller manager is also pod. Scheduler is also pod. These all components are pod in Kubernetes. Pod contains what? Pod
Containers,
contains
basically.
container. Correct, no? And container come from the image, the one
Right.
which you know very well. So same way, guys, these three component which I'm talking about, when we install the CD, Argo CD, then these API server, repository server, and application controller is nothing but a pod in Kubernetes. Okay, and
Mhm.
this Kubernetes pod has a container has certain image. This image will be given by Argo CD. That's all. So now you will want to know, okay, what is the job of API server? So API server is API server. Okay, if you understand the Kubernetes API server, you will understand this API server. Remember that. What is API server? I'll put it in my simple way. API server means what?
It listens to requests and response, takes
Uh-huh.
action, or
It's
uh,
like a provider of sorts.
No.
Any interactions you want to do with the platform, you have to go through the API server,
Huh. Correct. 100% right.
including your kubectl.
100% right. So here API server contains collections of API. Okay. Collections of API. How many? 56 APIs you have so far, which I can recall with my mind. Collections of APIs. This API, what you can do? You can do CRUD. CRUD means you can create, for example, pod. Create pod, read pod, get pod, update pod, delete pod. So these collections of API, we call it also microservice, okay? Microservice. Or we call it also function if you want to know function. One function, one API, one function, one microservice. So API server is basically, you know what? If you really look at the architecture, API server is your registry actually for Kubernetes. Are you understanding? What is registry?
Like a service registry?
Yes, service registry. So you create a service registry for your own application, right?
Hmm.
So Kubernetes also create a API registry, API registry for, and they call it API server. Make sense? So now
Right.
similar concept we have here also. In the Argo CD, we have API server, which is a registry for all functionality at one place. But how can you access? Through REST API. So this is the API server. It's a gRPC REST server. gRPC means Go RPC. Okay. There's a called RPC and there's called Go RPC. So this product, when you say gRPC, that means this product has been written in Golang. Okay, so it's a API server, a gRPC REST server that exposes the API that is consumed by web UI, CLI, and CI/CD system. Now I'll put it in a simple way. How do you consume the API server of Kubernetes? How do you consume?
One way you can
knowing
use is
get
kubectl commands.
kubectl command. That's a CLI, but we have a
Mm.
dashboard also. I hope you remember that.
yeah,
Correct, no? You might have seen it for sure. So you have a dashboard also, which you can use it. Okay. So like that also in Argo CD also, you can use the Argo commands also, Argo UI also, both way you can do that. And CI/CD system also you can use it.
So
CI/CD
this
system.
dashboard is not there in the native Kubernetes, right?
Native dashboard is not there in the core. So when you deploy the core, you won't get a dashboard UI, but we will deploy this complete package. So you will get a dashboard also.
Are you talking about the dashboard from like a Grafana or something else?
Oh, no, 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 no. I'm talking about the dashboard for Argo CD. I'm talking about the
Okay, okay,
Kubernetes dashboard is equal to Argo CD dashboard. We'll have a something similar dashboard for Argo CD also.
okay.
Okay. Argo CD has a command line also, CLI. So that's the Argo API server. So API server can be, Argo CD API server can be accessed through the UI, CLI, and so on. CI/CD system, I'll not talk about it. For that, we'll have to get into the different tool like a cloud-based Jenkins X and all stuff like that. And then we have a repository server. This is basically powered by Redis. Okay, this is a in repository server is powered by Redis. Okay, so what exactly that is? It's an internal service that maintains a local cache of Git repo holding the app manifest. It's basically cache. So internal service that maintains local cache of the Git repo holding the app manifest. App manifest means, see, simple way I'll put it up. Whatever you write in YAML file, I mean, whatever you deploy that declarative language in Git, that it download it and keep it in the repository server for the local cache so it can deploy in the Kubernetes. So it's like a local cache. Now,
Okay.
application controller is the main thing which I've been discussing through Notepad also. So application controller basically is Kubernetes controller. Okay, that continuously monitor. Remember, continuously means loop I said. I simplify that looping. Looping means never stop. So a Kubernetes controller that continuously monitor running app compare the current live state against the desired state in the GitHub, which we discussed already multiple times. So these are the three components which you have in the Argo CD architecture. I hope you are comfortable with it.
Yeah.
So look at this. Now this image you have to understand. It's the official image. We copied from there only. So first look at it, then I'll explain it to you. Okay?
Yeah, I think all the ways to consume Argo CD are the peripheral components, right? The UI, the
Yeah.
webhooks, which may be the CI/CD part of it,
Yeah.
and of course the three components: API server, repository, and application controller. That's a core components of Argo CD.
Yes. Yes.
So this K8 is shown in this red box. What is that? Is it showing that it's running on Kubernetes, or is it
Yes, that's what I said. No, it's a pod.
correct? It's a pod, right?
Yeah.
Okay.
So now I'll discuss. See here. First thing, focus on the middle image. The question is where to deploy Argo CD. So Argo CD you can deploy in the Kubernetes itself. So if you look at this image, there is a Kubernetes. We'll have to set up one Kubernetes. Remember, we need to set up one Kubernetes cluster where we should use it only for Argo CD. Theoretically, you can use it for your applications also. That's not a problem, theoretically. But as per this image, there will be one cluster for Argo CD deployment only. And in the Argo CD, that particular Kubernetes will run these three components. It's just a one YAML file. Don't worry about that. Just very simple deployment. If you set what we will do, we'll set up one Kubernetes cluster, deploy Argo CD, one is ready, that is ready. And then we'll see that API server is a pod, a repository server is pod and controller. Okay, clear all of you so far? I mean that middle part.
Yeah.
After that, the question is how do you access? So guys, you can access the Argo CD API server. Yeah, remember that. When you in Kubernetes, you access through kubectl API server. So here we need to access through to the API server of Argo CD. But the question is how do we access? You can access through the dashboard or CLI. Okay, CLI this dashboard and CLI you can have it anywhere. So CLI typically you will install in your workstation. That means your laptop. From laptop, you will make a request to the API server, or you can have UI also. Now the question is, where do we run a UI? So most of the time, UI you run inside a Kubernetes cluster only as part of add-ons. Correct now? Correct now?
Yeah.
Yeah. So that is done. So top image is explained properly.
So, question: does Argo CD have its own CLI, or do we use kubectl commands here also?
No, they have. Okay, understand that. Any theoretically, I am talking about. Okay, please understand. API server, repository server, application controller. These all are pods only. So theoretically, you can access and manage through the kubectl only, and you can edit, create, read, update, delete. You can do through the kubectl also. Correct, now?
Right.
But we have a CLI, Argo CD CLI also, dedicated CLI, and for that only API server is there. No, this API
Okay.
server for Argo CD is there for understanding the CLI of Argo CD.
Okay.
Getting my points? But theoretically, you can do changes directly also, no problem.
Right.
Okay, and then UI part we have. So top image is clear, right? All of you.
Right. Right.
Now left
So
side.
UI runs as part of another pod, or it is again
No,
built in that
UI.
API server?
Sorry. Sorry. UI will be running in the same cluster in another pod. It cannot be same multiple applications, same pod you cannot be, right? Multiple pod. It has to
Right.
be.
Right.
Okay. So if you want to run it UI, then API server you have to register it. By default, it will be there. And then UI you can expose to the service at the load balancer or node port, so you can access from your laptop. Service node port, you know that, right?
Yeah.
And load balancer, so that is okay. So top front is clear, right? Top architecture is clear.
Mm-hmm.
Yes.
But
Now
what
left
is the
side,
left one?
left side, remember that Argo CD do what? Do what? So Argo CD using the controller, application controller, they check the your manifest file. Manifest means your desire. Where is your desire? In GitHub. In this case, it's GitHub. You can use it any other hosting platform. So here Argo CD always check. Okay, what you desire, what you desire, what you desire, what is your desire? Are you changing? Is it in sync? Desire means your YAML file, your Helm packages, your customization package. Are you understanding?
Mm-hmm.
Right.
And if there is a changes, what they will do? If they will deploy, look at the extreme bottom section, they will deploy that changes in your application Kubernetes clusters. These are the small Kubernetes clusters is there, right? Icon. So that is
Mm-hmm.
your application clusters of Kubernetes. Understood?
Yeah.
Are you understanding?
Right. And can you just talk about the webhooks
Yeah, now
working? Is it?
that's the last point.
Yeah.
So all this image is clear. Now see here, when something happens means what? Something happens means your desire versus application is not in sync. So you want to get a notification for some email or something like that. Okay, just one case scenario. See, Argo CD detects your application and GitHub is not in sync. And due to some reason, there is no sync happening. There's some reason. Why? What reason? Maybe you have written wrong YAML file. Maybe your application is not running, controller is not running, your deployment is having crashing the pod. Crash pod can happen, right? Depends on your bad specification. Service is not able to do the test, that means health check. Pod health check is not functional. So all these kind of problems which will detected by Argo CD and they will notify you. So if any problem happens, when you want to trigger and notification means email, SES or maybe Slack message or something like that, then you can use the webhooks which is built in Argo CD.
Okay.
Now webhooks can be used for triggering the CI also. CI means Jenkins X. That image which you see is a Jenkins X image. Okay, so if that, let's say the deployment got failed, state is not coming up, so immediately they will call, they may trigger the CI, it will build automatically, create an image, new image, and everything will automatically again redeploy. Everything you want to automate, right? So here webhooks means simple things. There are certain events which we have in Argo CD. I'll show you that. On that events, you want to trigger email or chat or CI tool or some SES, SNS or whatever it is, then it can be used. Make sense?
Yeah. What is that first logo next to Slack on the
Azure.
left? Azure. Oh, okay. Oh, that's interesting.
Yeah.
Right. Right.
So the Azure, Slack, Jenkins CI, Google Cloud, AWS.
Right.
Here, this logo is Azure, not Azure DevOps.
Right. Must have been a specific
Yeah.
service of that. Right.
Got it? Architecture?
Yep.
Yeah.
Yeah. So theoretically, what we need to do? Nothing great. You are not doing something great, which you know that. We will deploy two clusters, each one of us. Okay, two Kubernetes clusters. One cluster we will use for deploying Argo CD. Okay, and second cluster will use for deploying Argo CD application through Argo CD. That's all. And then we will access this UI and command line. Hello.
Yeah.
Yeah. So we'll
We're
access
able to hear you.
that. Yeah, through CI and command line and get going, and we'll put the desire in GitHub and continue working on it. Got it?
Okay. Yep.
So guys, these are the components. Okay, Argo CD components. which will working with it extra component actually. So here Argo Dex server, okay, Argo Dex server, Argo Metrics server. We have Argo Redis, Argo Repo server, Argo CD server. Okay, so these are the when you deploy Argo CD, these are the deployment and services will be created. Okay, when you deploy the Argo CD, these are the deployment and services will be created. So what exactly the role of Argo Dex server? Argo CD embed the bundles of Dex as part of its installation for the purpose of delegating authentications to the external identity provider and handling SSO. That means in a simple way, if you want to enable that Argo CD authentication and authorization using the SSO and so on, this will be used for that. Argometrics, what it will do? Argometrics means all the matrices which is being managed by Argo CD pods, services, deployment, all blah blah blah. You can access through Argo CD matrices. So what you can do, Argo CD matrices, you can feed this data into the Prometheus, and from the Prometheus you can use the Grafana to visualize those matrices of Argo CD. So if you really want to monitor Argo CD, you can use this data. I hope you know Prometheus and Grafana, so it will help you to easy to understand this. Correct?
Right. Yeah.
Now, Argo CD Redis, you will see the deployment as part of it. So Redis basically used for this cache as said, right? Repository server. Okay, so that is used for the repository server. Argo CD repo server. So Redis is running, but repo server is on one applications. Both together in conjunction they work actually. So clone the Git repository, keeping it up to date and generating manifest using the appropriate tool. And last one, run the server Argo CD API server, which is basically the first component. So these are the deployment and services you will see when you deploy the Argo CD components. So other supported tool which is with the Argo CD, supported tool means what? What you will have in the GitHub, something like that. So so Argo CD reads, see here, look at the arrow. Argo CD reads GitHub, but not only GitHub. Many tools it can read. So Argo CD can read the YAML file for customize the one which I was discussing with you. Argo CD can read the YAML file for Helm. Argo CD can read the YAML for Kesonet. Argo CD can read the YAML file for Jenkins pipeline. Argo CD can use JSONet also. So I'll use this Helm and stuff like that as part of this session. Okay, so what are the detection method which we have in the Argo CD? So when you use the Argo CD and create an app on top of it, so immediately Argo CD is able to detect the tooling used to create that app, that all these things happen automatically. Okay, so if the JSONet and Ksonet, if there is a two files, one named with app.yaml and another one is with the matching with star.jsonet, then basically it's a JSONet automatically read. If it is a Helm, then char.yaml. If it is customization.yaml. So yes, automatically they detect and find out, okay, which particular tool it's basically supported with. So every tools, they have some custom files and get going. So what we have covered so far, in this module we gained the understanding of the containers, Kubernetes, as well as Helm and customize, brief understanding of the GitOps, including its history, code concept, and even GitOps operators, overview of Argo project, a core solution with the focus on Argo CD. Then we explored Argo CD and what it is and what does, including the top features, history, architecture, and supported tooling, and why it is important. So, any questions so far?
Okay, thanks, Rajesh. It's good to know that such tool exists for applications. But if you have to call out from your experience for a tool that manages our platform, what would?
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to hundreds of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.